process for advanced behavioral sciences. Yes, it's being recorded, which is perfect. We have the technical issues, so we are slightly later, but I'm sure all the speakers get started. Talk to us about signaling or identity. Oh.
Yeah, thanks for coming on the last morning of the last day. Let's see. Before we get started. I'm going to talk about some stuff that I work on. I think social identity is super important. I know at least some of you agree, and hopefully the rest of you will be convinced by the end of this. I've really been enjoying this conference. I've never been to this meeting before, and so it's really cool to see this kind of community. And it struck me that there's something kind of interesting about a community that's really dedicated to modeling, which is that, I think of science as having several components, and you could break it down into this, right? We have the theory, which is our explanation for how things in the world work generally. And then we have data, which is our measurements and discoveries about the things that we see in the world. And our goal usually is to try to connect these things. Say, okay, we understand how things work. We go and find measurements to see if we're right or make new discoveries to revise our theory. And modeling is this kind of intermediary where we're very rarely interested, other than as a kind of playful exploratory exercise, in the details of the model themselves, but more in how they inform either the theory or the data or both. And this is used in a few different ways, right? We see this kind of atheoretic data analysis a lot, especially in communities that don't do a lot of modeling, or like just statistical modeling, where we have general models and we try to fit them to data, and then we see, okay, now our explanation is right because the models fit the data. And the theory is informing our data explorations, but not so much the modeling. That happens a lot. You also get this pure theory all the time, right? So sometimes we just want to explore formalization of theory and use models to aid theory development. And here data is used in service of driving the theory development, saying, okay, we see the data, we get ideas about it, and then we're using modeling to formalize that theory and see what happens when we make theory that way. But we're not really directly matching it to data. I think both these approaches are fine and good and should continue and are important. I also think, though, that this is what we ultimately want. We want a cohesive, quantitative, theory-based science of human beings. And here the modeling acts both as a facilitator that helps develop and improve theory, and also to drive data collection, while being actively shaped and improved by both the theory and the data. So I think this is ultimately the goal for social science. And I cannot promise to fully deliver on this vision today in this talk. But I think we ought to take seriously the opportunity to develop more rigorous, theory-driven, quantitative social science with the skills and knowledge we have as interdisciplinary modeling type people. So with that in mind, I want to talk a bit about a project, or really a set of related projects that I've been working on. Oh no, what did I do? So a lot of the work that I'm going to talk about today is reviewed in this short review paper. So in case you want a slightly more stationary summary of this work, feel free to check this out. Did I do something wrong?
Just start the video. Can you start the video? What? Can you start the video?
Start the video?
Yeah.
I don't understand what you're doing to me. Oh, start video. Yeah. Yes, now you get to see my keyboard, people online. Okay. Okay, so I'll start with an observation. which is that humans assort in non-random ways. This is obvious, we all know this, but it's important when we do modeling, right? Because often the sort of baseline assumption is to ignore this. So some examples, this is mostly drawn from the US, but similar things are found in other countries. So this is, every little square here is a county in the US. And the color is based on how the county voted in the 1976 and 2004 presidential elections. Now I pay attention to the white squares, right? The white squares are the competitive counties where the vote went one side or the other by less than 20 percentage points. You can see in the 70s, a lot of close calls. And in the 2000s, not so much. Right? And in addition to a little bit of gerrymandering, this is mostly driven by people moving around and assorting with people who they feel more comfortable with, who tend to vote the same way they do. So most counties are pretty solidly one party or the other, and the competition is for who the candidate will be, not ultimately which party will be in power. See this in the way people assort online too, not just their physical neighbors, but their online neighbors. So most people on Facebook tend to be Facebook friends with people who vote the same way they do. And it's not just political identity, it's all kinds of things. So this is a map of New York City, which is where I'm from. And it's data taken from the 2010 census, but the 2020 data looks basically identical. Every color is 120 people, and the color, sorry, every dot is 120 people, and the color is their ethnicity as gotten by the census. So we have mostly white people here in Manhattan, and mostly Black and Hispanic people here in Brooklyn, right? A lot of Asians in Queens, right? And it's very ethnically segregated. This is the point that Schelling was trying to explain back in the 70s. And you see this in lots of cities, certainly in the US, and in a lot of cosmopolitan diverse cities around the world. So people have identities and they signal those identities in kind of interesting ways. And they communicate what they're like. So here we have two groups of people. Ethnically, they're not that different, but you can have a lot of different expectations about what they're probably going to be like. This is a group of East German punks in the 1980s, and this is a group of Chapman University MBA students. I think we can agree that if you were to approach them, you would have different expectations about the way they would respond to you. So humans mark themselves in interesting ways, and in terms of political identity, which we'll talk about some, we do this too. In the US, it's kind of crazy. So here we have two people who are very big fans of Bernie Sanders, who is our sort of mainstream left politician, and they have tattooed themselves with images of him to really signal their dedication to the cause. And here we have two people who are really signaling their dedication to neo-fascism. So I'm going to talk a lot about identity signals. And so what I mean by this is any component of communication transmission, displays, language, behavior, marking that informs receivers of your membership in some categorizable subset of individuals. This is really, really important because our own identity and the way we perceive identity signals from others is going to inform our perceptions and our decision making. I think this is important for modeling and understanding human behavior. So I'll just give a quick example here. This is an empirical study I was involved in, led by Maya Powell, who's a graduate student in the applied math department at my university, and her advisor, Ronald Kim, and myself. And so we were interested in responses to tweets marked with either the Black Lives Matter or All Lives Matter hashtags. This was all in the wake of a lot of the racial protests. This is right after we got all these tweets right after the killing of George Floyd. And what we asked people was we just showed them these tweets with and without the hashtag taken away. And we said, is this racist? And is this offensive? This is how one says, do you find this offensive? And the x-axis is political orientation. And you can see that right-wing people tend to find this offensive and racist. And importantly, the hashtag serves as a kind of marker. It's not just contextual, right? It's saying, okay, in case you were wondering what this is about, this is the identity affiliation that's associated with this. And when we look at All Lives Matter, we see the exact same pattern, but for the left, right? So left-wing people find this more offensive and more racist, and the presence of the hashtag makes a big difference. And we actually even did this with neutral tweets, where we just artificially added the hashtag to tweets that had nothing to do with politics. And especially people on the left get very upset if they see All Lives Matter, even if it's like, I walked my puppy today, hashtag All Lives Matter, which is a kind of messed up thing to say. So this seems really bad, but I want to make the argument ahead of time that it's not necessarily in itself a bad thing. So I think parochial social learning may actually be really adaptive. By parochial social, I mean preferentially learning and preferring information from people who are similar to you. And there's an argument that was made by Rob Boyd and Pete Richardson in their 1985 book, which is, personally, I'm biased, but I think their work is like the most important work in social science. And I think if you're interested in modeling social processes and social change, it really behooves you to get to know the work of Boyd and Richardson. So we're humans, we're incredibly social and cultural, and we rely on social learning desperately. Obligatorily. And especially when there's times of uncertainty and environmental variability. And the effectiveness of social learning is diminished if we have low inter-individual correlation. So if you are in a different environment than I am, or you have different affordances and networks and opportunities than I do, then me trying to copy what you do is not going to be effective. And so I want to increase the correlation between myself and you in order to learn from you. And social identity some have argued, including myself, can serve as an adaptive cue for identifying targets. A big related thing that social identity helps with, that there's more formal work on, is cooperative assortment and coordination. And I promise I'll talk about modeling really soon. So we have this issue where we have different norms and expectations and goals, and it would behoove us to find people that have similar norms and expectations and goals in order to more effectively coordinate our expectations and goals and cooperate. And so what we want to do is, let's say this is an imagined model community where there's two norms. There's the purple people and the green people, and they have different norms, and purple people do better when they interact with other purple people. Same with green people. But there's a problem. It's because we're not actually green and purple, right? We're just people. And you can't tell if somebody is green or purple just by looking at them. So what do? Right? So some sort of overt marker is usually the answer that's proposed. This has been proposed by lots of people: Frederick Barth, Robin Dunbar, Richard McElreath, Boyd and Richardson. And this works very well. If all the purple people wear purple hats and all the green people wear green hats, right, then everyone assorts and they get this awesome coordination bonus and everyone is happy. This is really important here, and there's a nuance to this that I'm going to explore in a little bit, but I want to take a brief pause before I do that. So assortment isn't always good, as you might imagine. I was really influenced by, there's this really wonderful paper by Marcel Salate and Sebastian Bonhoeffer from 2008, where they were looking at social networks and vaccine adoption for some imagined pandemic. And what they did was they looked at a few different network structures, and they said, you know, the way network epistemology, epidemiology has been around for a while, people have understood how contagion spreads in a network. But the way vaccines had usually been explored was under the assumption of random vaccination. And so, okay, you can calculate a vaccine threshold. You need to vaccinate some proportion of the population to get herd immunity, and then you're okay, right? And I think a lot of us have become very familiar with this if we hadn't already been in the last few years. The issue is that people don't get vaccinated at random, right? They get vaccinated in social networks. So people who get vaccinated tend to be in networks with people who get vaccinated, and people who don't get vaccinated tend to be in networks with people who don't get vaccinated. And this makes a huge difference. And so this is just a really simple model that shows it. And this is just the extreme cases where you have maximal clustering and minimal clustering, same proportion of vaccination in all cases. And you can see that for some level of vaccine coverage, the probability that an initial infection turns into an outbreak that spreads through the network is much, much higher when you have clustering, right? Because you get these big clusters where no one's vaccinated, and so it explodes. A related phenomenon I'll briefly mention is, you can't read this, but it says outgroup aversion, which is just, I'll define as a reduced inclination to adopt a behavior or a product when it's associated with an outgroup. So this is my sort of group 2 example that if you aren't familiar with the insanity of the US, buckle up. This is really popular in certain rural parts of the country in the sort of late aughts, early 2010s. This is a phenomenon called rolling coal, where when hybrid electric vehicles started getting popular and promoted, people, okay, you know, it'd be good for the environment if we all adopted more energy efficient hybrid cars. Some people said, not only are we not going to do that because that's associated with leftist hippie bullshit, we're going to pay money to attach exhaust pipes to our trucks that blow out unfiltered exhaust that we can push a button and aim at people who are driving Priuses or riding bicycles. And there's actually in the news about last year where there's a teenager driving this that blew smoke at a bunch of bicyclists and caused a big accident, and a bunch of them got really seriously injured. This is now illegal in most states, but for a while it wasn't, and it's really terrible. So I did a model a few years back just looking at the effect of outgroup aversion on behavior or product adoption. But it got us thinking, as soon as COVID broke out, Jamie Holland-Jones and I, Jamie is an epidemiological anthropologist at Stanford, built a coupled contagion model where there's both simultaneously behavior contagion and disease contagion, where we have two groups. They interact with some rate, but they can also be homophilous, so they mostly interact among themselves. There's a product or behavior that is spread, and we assume that that behavior is preventative of disease transmission. So mask wearing, vaccination, social distancing, etc. And what happened, right? Well, when there's no outgroup aversion or homophily, the gray lines are the product of the behavior adoption, and the pink lines are the infection rates. You get kind of a classic SIR curve, which is what it is. It's an SIR model. And the disease breaks out first in group 1, so they get hit pretty badly. And then they adopt the behavior right away. It takes a little longer to get to group 2, so they get a slightly higher peak, but both of them then do okay, and we have a maximum infection rate of about 5 or 6%. In the same model, when we have outgroup aversion and they don't like each other, right, all of a sudden we get a lot less adoption in both group 1 and group 2. And you can see the proportion being infected is now closer to 20%, from 5%, with a stronger infection peak in group 2, even though it initially breaks out in group 1. And if we have homophily, the effect is magnified, right? Where we get this outbreak comes into group 1 and then spreads into group 2 later, after outgroup aversion has really taken hold, and we get a much, much higher peak in group 2, and then this kind of second wave in group 1 as it feeds back from group 2. Now we put out this preprint in late spring of 2020, and it's not quite that severe because the model makes some assumptions, but here, I meant to have a better slide on this. Yeah, okay. So behaviors have become politicized, and outgroup aversion seems to have taken hold, at least in the US. It's insane. This is an amazing and shocking graph that every time I look at it, I can't believe it. The x-axis here is the proportion of people in every dot here is a county, where the size of the dot is the population in the US. And this is the x-axis is the proportion of people in that county of the votes that went for Donald Trump in 2020. And this is the percent of people in that county that are fully vaccinated for COVID. This is R squared, 0.52. Right? It's massive. And when you look at, this is death rates from COVID, which is slightly different than infection rates. But you can see, initially, like everywhere, it broke out in populated urban areas, which tend to be left-leaning, so blue, more Democrat. But then, as vaccination and social distancing adoption came on board, we get this flip-flop where now most of the deaths are in Republican counties because they don't vaccinate themselves or take any preventative measures. Things are changing. It's a changing landscape all around. So this kind of work I think is really important, but I also think what this is doing, what all this is doing is saying we have an idea of how social identity works and signaling works at the individual psychological level. And we're going to put that into a social model and say, what happens when you have a whole population of people that behave this way? And this kind of thing is really important, not just for identity, right? We do this all the time for all kinds of things. We say, this is how people update their opinions. What happens if there's a whole population? This is how people share, do norms. What happens if there's a whole population? But another kind of question we might want to ask, right, is how do we expect people to actually use social identity signaling in the first place? And that's a different kind of question. I think we can do both of these things with model. So we can model the consequences of social identity. We assume we know how social identity works. But we can also try to understand how identity signaling itself works using kinds of models. So I'll talk a little bit about some of this work. So we can have overt signals that are very clear, unmistakable like these, but we can also have more subtle signals. And we do this a lot. Say, drop a reference, make a joke. And this is really valuable because let's say we're a green person or a purple person, and we're interacting happily with our other purple people. What this kind of thing does is it also burns bridges between these groups. It says I'm not interacting with the green people if I'm a purple person. And maybe that's okay. Maybe you don't want to interact with the green people. They're just too different from you. But purple people aren't homogeneously purple, right? There's still a diversity. So they're not really purple, right? They're different shades of blue and green, blue and red. And you might want to interact with some people who are more similar to you because they're going to get you better. You can work together more when you can, but we live in a diverse society. We all have to interact with people who we don't perfectly match with. I mean, we can all imagine instances where we have to interact with people who are not perfect fits for our modes of being and beliefs. So, between groups, we can use ethnic markers or overt signals, and this allows assortment on norms, but it burns bridges between groups. Within groups, it might be possible to assort on norms when possible, but also cooperate with people who are imperfect partners when it's necessary. And this is an idea that was really well articulated by the economist Glenn Loury in his 1994 paper on self-censorship. And this is a quote from that paper. If the significance of some words as signals of belief is known only to insiders, their use in public allows the speaker to convey a reassuring message to some listener, I share your values, without alarming the others. And I'm going to propose that people do this all the time. So the most widely known way of doing this is political dog whistling. Political candidates do this all the time. Again, I apologize for the US-centric nature of the examples. It's just where I'm from. But this is, this is George W. Bush in the 2004 US presidential debate. And in that debate, he made several references, and in other speeches to Dred Scott, the Dred Scott Supreme Court decision. So if you don't know, this is a 1857 Supreme Court decision where Dred Scott, a black man who was born a slave in the South, was brought to the North, which did not have slavery, and then his former owner tried to bring him back, and he sued for his freedom. He went to court, and it went all the way to the Supreme Court, and the Supreme Court in 1857 ruled against him, saying that as a black man at that time, pre-Civil War, he did not have the full rights of citizenship. He could not be a citizen and therefore couldn't sue for his freedom. So he lost that case. This case was a really big deal in kind of catalyzing abolitionist forces and probably fomented the Civil War a bit earlier than it would have happened otherwise. George W. Bush, contrary to what you might think, was talking about how bad this decision is, what a terrible decision this was. And it was. I think we can all agree, it's a terrible decision. everyone should agree that this is a terrible decision. Why is he talking about how terrible a decision it was and trying to make this point as a political point when everyone on both the left and the right in the US now, at least publicly, will agree that this is a terrible decision? The reason is that in far-right evangelical Christian communities in the US, this was a common analogy to the Roe versus Wade decision in the 1960s that legalized abortion until very recently in the US. And so the analogy that that community had been making was that this was a terrible decision that the Supreme Court, where the Supreme Court made a mistake, in the same way that Roe versus Wade was a terrible decision where the Supreme Court made a mistake. And so by talking about this, he could signal directly to those communities, I understand you, and I'm signaling to you my commitment to overturning abortion, while not upsetting both people on the left and also more moderate people on the right. So politicians do this all the time. But people do this all the time in more general interactions, right? People like Tom Flamson have proposed that a lot of humor is funny. The funniest people you know are usually the people who are your friends. And that's because signaling humor can act as a sort of honest signal that I am similar to you, and therefore we're going to find the same things funny. But you know, it doesn't have to be humor. Fashion serves as a kind of covert signal, especially people who are really into fashion. You know, tend to prefer things that are marked more subtly or less obviously. So this is, I had to look this up. This is a Tory Burch bag. It doesn't say what it is on it, but it's twice as expensive as the Coach bag here. And the people who are really into fashion like it. Political dog whistling I mentioned, but also, you know, sort of invisible minorities. So members of the LGBTQ community in certain places might have to signal covertly. There's this really nice sort of visual ethnography from the 70s by Fisher looking at different sort of coded ways of dress that gay men used in the 1970s in San Francisco. And also political dissidents. So let's say you live under an authoritarian regime. It's really important to find other dissidents so you can get together, but very bad to be caught. Right? So more subtle or encrypted signals are really important. So this led us to develop a theory of covert signaling. So this was originally developed by Tom Flamson, myself, and Richard McElreath. Covert signals are just identity signals that are, in general, actively received by their intended audience, people who are similar, and not by others. So this contrasts with the overt signals that I talked about. And we can use modeling to ask what conditions are going to favor the evolution or cultural evolution of more covert signaling strategies. So here's a model. Goes in 4 stages. Signals are transmitted, receivers form attitudes, individuals assort for a cooperative task, and payoffs from those tasks lead to differential fitness, which can activate evolution. And this is actually, it's not actually one model, it's 2 models. There's a pure math model and an agent-based model published in these 2 papers. The last one just came out this past year. I'm going to focus more on the agent-based model because it's more fun. But both models basically work like this. So signal transmission, where individuals can either signal overtly, which is received by some proportion of the population, no matter how similar they are. It's like wearing a purple hat. And covert signals, which are noisier, received by fewer similar individuals, but nobody who's dissimilar. There's also receiving strategies that co-evolve with signaling strategies. So if you don't know somebody or anything about them, you can be neutral toward them, not one way or the other, or you could hate them and just say, I don't like anyone unless I know that they're like me. You can probably imagine people who are both of these kinds. And this is important, right? Because if you imagine everyone is churlish, that's a word we've used, then covert signaling is not going to be that effective because it doesn't matter if you avoid signaling what you're like unless you are actively trying to deceive someone. And we've sort of ignored deception for the case of this study, but it's on the list of things to look at. So once people have signaled and received the signals, they can do cooperative assortment. So we have homophily that we vary exogenously in the model. So when there's perfect homophily, you can always interact with people only preferentially the ones that you like and always avoid people you dislike. When there's no homophily, it's all interactions are at random, and otherwise it's in the middle. Sometimes you get to interact with people that you like, sometimes you don't. And then we get payoffs, and these are the main assumptions, right? One is that similar pairs do better than dissimilar pairs. So it is actively beneficial to find someone who's similar to you, but also that being disliked, which means someone knowing that you're different, is going to activate a cost. Now that cost could be 0. If you're like, it doesn't matter, I like everyone equally. But it could also be negative, like, oh, you're against the regime, off to jail you go, right? And then individuals with higher payoffs reproduce their strategies. So both their signaling and receiving strategies. So in the agent-based model, it was really important to make it so that it didn't have to be distinct groups. You can imagine a diverse population that has many traits. And here we've just done a vector of discrete traits, just binary traits on or off, and just said, okay, everyone has k traits, and your similarity to someone is the number of those traits, the fraction of those traits that are the same. And we use the threshold S. Say, okay, if at least S, a proportion S of traits are similar, then you're similar and you get a coordination bonus, otherwise you don't, and it sucks. And then if you're into evolutionary modeling, reproduction is through a Merced process, but it's not important if that's not something that's familiar to you. Okay, so the main biggest take home, which shouldn't be too surprising, is that covert signaling evolves when homophily is low and the cost of being disliked is high. So this is the proportion, the density of covert signalers in the population on average. Here is the rate of homophily, here is the cost of being disliked. So if you can always interact with someone who you like and always avoid people you don't like, then you should signal over, right? Because that way most people know who you are, and you can easily find partners and avoid non-preferred partners. But if homophily is imperfect, you might want to signal covertly. Now, you don't need to do so if there's no cost of being disliked, but once there's a cost, and it doesn't have to be that high, then covert signaling gets favored. And also, we've just found that generous receiving pretty much always co-evolves with covert signaling. So these things are connected. So this on the x-axis is the prevalence of churlish receivers, so not generous receiving, and here's the prevalence of covert signaling. You can see they're negatively correlated. So all right, good. Another thing we find is that, oh, it's totally obscure. Well, that says covert signaling is favored in more diverse populations. So we can use S as a measure of diversity, because S is how similar someone needs to be to get a coordination bonus, to be sort of deemed similar. But what that really means is that when S is high, we need to share a lot in common in order to really be, get that bonus. When S is low, we only need to have a couple things in common. And you can imagine this is like the difference when most traits are about trivial things, like what kind of sports team we might like in a country that doesn't care that much about sports, or what kind of movies or music we like, it might be important, but maybe not. Whereas this is maybe an issue where the traits are like what religion we are and how we feel about certain political issues. And when the similarity threshold is higher, we get more covert signaling. Covert signaling is favored. And this is just one case of this W homophily, but you reproduce this pattern for pretty much all values. This got us thinking though, because not everyone has the same response to diversity. Some people, so what this is basically varying the probability that a random person is going to be similar to you. But that's not the same for everyone. Right? Some people, if you're a majority person, most people are going to be similar to you. If you're in the minority, most people will be different from you. And so we've created a minority and a majority class where slightly less than half the traits are fixed. So everyone in the majority has the first 4 out of 9 in this case traits fixed at 1, and everyone in the minority has the first 4 out of 9 traits fixed at 0. So most majority people are going to be similar to most other majority people, and most minority people will be similar to other minority people, but not to each other. And there's a little bit of noise in between. And what we find, maybe unsurprising at this point, is that covert signaling is favored among minority groups. So in these cases, we can bring homophily. So the green is the majority, the orange is the minority, and you see more covert signaling among minority groups in each case. They have more of an incentive to avoid being detected by people who are dissimilar from them. So here are some model predictions, right? See, covert signals are going to be favored when, one, cost of being disliked is large, and two, people are more likely to encounter dissimilar or out-group people. And these conditions, especially the latter condition, is met when people more often have to interact with partners they didn't choose, people live in more diverse populations, and people are members of a minority group. So these are the model predictions. And we really wanted to test this. It turns out covert signaling is really hard to test because sort of by definition, you're not dealing with signals that you only detect if you're a member of the preferred group. So how do you do that? It seems impossible. It's not impossible because we did it. It's really, not easy. I feel very, very fortunate to have worked with this amazing team, Merced, Tamara Vanderdoes, and Zach Donovan. We asked, do people strategically alter their signaling behavior in a way that's consistent with the model? So this paper just came out in PNAS some months back. What we did was somewhat complicated, and I'm going to kind of gloss over it for an interest of time. But basically, we got a bunch of tweets from the Twitters, and we targeted people who follow either mostly far right or mostly far left accounts, and then we looked at those people's follower networks. And we got a lot of information from them. We collected a bunch of tweets. And importantly, we collected tweets in the months only from Americans and only in the 6 weeks before the 2020 presidential election, when a certain thing was very, very salient. Not just a presidential election, but it was also right after the George Floyd murders. And it was right after Amy Coney Barrett was kind of shunted into the Supreme Court, who was kind of a last-wing, far-right person. There was a lot of tension in the US around this time, so a lot of people were signaling politically. And then we took those tweets and we showed them to people who were either on the far or moderate right or the far or moderate left. And we used the differential responses, sort of assuming that people on the fringes, radical people, would be more attuned to both their own and the other side messages, whereas people in the middle would be more likely to recognize tweets from their own side, but not from the other side. And we use those differences to identify candidate tweets, covert tweets. And we validated this in a number of ways. The first finding is that when you just look at the tweets themselves, you see two things. One is that Twitter users with more heterogeneous follower networks use more covert signaling. Now, they signal less in general about politics. So here's the more light is more homogeneous, dark is more heterogeneous. So you can see generally people with more heterogeneous follower networks tweet less in general in all cases. But when they do, they're more likely to use covert tweets rather than open tweets. But this signal is not that strong because, as I said, people are assortative and tend to follow people with similar views. So we did a behavioral experiment where we gave people a bunch of tweets that were from their same political side. Some were covert, some were overt. They didn't know which was which. And we just said, a bunch of these, you can pick as many of these as you like. And we're going to show them to an audience. We actually already shown them. Just like you rated tweets, other people have rated tweets. And if you pick a tweet that most people liked, you get more money. And if you pick a tweet that most people didn't like, you lose money. And then we said, okay, of this group, it's going to be 10 people, and 10 of them are going to be members of your own party, and the rest members of the other party. And what we see is that when you're a minority, you tweet, you're more careful with how many you pick, and you pick way fewer tweets. People took longer in selecting their tweets, and those tweets were much more likely to be covert tweets. We got a very small, marginally, barely statistically significant effective cost, but when we analyzed it, it's probably because the difference in the low cost and high cost condition was about 20 cents, and it just probably didn't matter. And we did actually, I'm not going to show it, but I did a mathematical model that predicted that the effective outgroup would be much higher than the effect, larger than the effective cost, so at least we got that. Okay, with my last, how many minutes do I have left? 5-ish, okay. So, but really was excited, it was nice to be able to kind of test something at least somewhat. But it got, thinking, like, the real world is different than the model. In the real world, in the model, all members of the outgroup don't receive a covert tweet, whereas here, some people do, right? Less, but some people do. So there's room for variation. Also, we had to be really careful in looking at tweets in a very specific time frame. And that's partly because our models were agnostic about how people choose signals to be overt, covert, and what those signals were. So the experiments looked at specific signals at specific time. And here's the idea, right? If outsiders have incentives and can learn about others, then covert signals might not be covert for very long. If you keep signaling covertly, eventually other people are going to say, hey, seems like people who do that are always members of the other group. And then it doesn't become an effective covert signal anymore. So maybe there's dynamic cycles. So Zach Donovan and I have recently done an agent-based model. This will be a preprint in the next month or two. The proposal here is that signals become established conventionally through regular, a lot of us are familiar with the way that conventions sort of arise and emerge in models and in real life. This works the same way, but here, right, outgroup members can also learn through exposure, and if being recognized as costly, a once established covert signal might have to become overt or be discarded. And so if the incentives to signal covertly are still there, then there'll be incentives to come up with new signals. So we built a model where we have, signals. An in-group has a bunch of signals they can use, and the more they use it, the more they like using it because it works among themselves. But there's also an out-group that's learning about the signal, and the more the out-group learns about the signal, the more it's bad to use the signal if you remember the in-group. Now, this kind of dynamic might be familiar to a lot of you, right? It's very similar to ideas about fashion cycles, like those proposed by Gary Zimmel, but it's also really similar to these kinds of cyclical phenomena, the way they're modeled with predator-prey dynamics. Here's endoparasites competing, neural firing rates that are coupled, and even like sort of Peter Turchin's work on the rise and fall of empires. All these use kind of similar ideas. Our model's a little different because we're going to use explicit learning dynamics. So we model agents with reinforcement learning. And so I don't have a ton of time, but the basic idea is that in-group agents have a signaling repertoire. Each agent has a weight for each signal. Each one selects a signal based proportionally probability based on its weight. And then if another in-group agent recognizes that signal, they're like, yay, that's an effective signal. And they're more likely to use it in the future. There's also an out-group. Oh, yeah. Out-group agents also occasionally receive the in-group signals, and they might learn about an in-group agent's identity if they use a known signal, or maybe by accident, and they accidentally reveal themselves. And out-group agents also learn about signals, and if an in-group agent is recognized by the out-group, it's potentially costly, and they might be less likely to use that again in the future. And so 3 different kinds of dynamics emerge. We get stasis, where one signal is dominant and remains dominant. We get cycling, where different signals come and go. And we get noise, where basically it's so bad to be recognized that no signal gets established. And these are the 3 outcomes that always happen. And it's hard to use just sort of identify these in the data. So we used machine learning. We used a random forest trained on human observers' ratings to detect when the outcomes was one kind or the other. And the main result is that cycling is more likely when interactions with out-group agents are more costly and more common, which is probably what you'd expect. Okay, so summary. Identity signals and parochial social learning are probably adaptive in many cases, but they can backfire in cases where collective goals transcend and benefits transcend identity boundaries, like in the contagion case. Identity can constrain information flow and behavior and dramatically alter population dynamics. So it's really important to consider it in our models. And a lot of you have, which has been really exciting to see. Identity signaling involves multiple strategies, the relative benefits of which can be culturally and contextually dependent. And we can use modeling to understand those contexts. And finally, if we understand the forces driving the adoption and disadoption of signals, we can also understand their life cycles. I'm really excited. We're in the process of developing behavioral experiments that will try to help kind of refine the theory that we've been developing with the models. And hopefully in a year or so, I'll have data from those. Okay, I just want to briefly mention, because I don't have time, that I have a book coming out. It's going to be out next year. It's called Modeling Social Behavior, and it's got math models and agent-based models. And it was really designed, it's been based on the graduate course I teach. It's got a lot of topics that I think would be interesting to people in this crowd. So stay tuned for that. By this time next year, hopefully we'll be able to be in your hands if you so desire. So yeah, that's it. Thank you so much for the time.
Just a few questions in terms of technical issues. I'm going to limit it to 5 questions, and you're on 1 minute per question and answer speed. Take that into account when posing the question. You read the time of the answer. May I have 5 candidates, please? And you can stand up and be more visible. We know this is a question. So let's see, on the left-hand side, you have the majority, that's like 3 questions, and on the right-hand side, you have a minority, and 1 question, and then a small question like maybe for someone else in there. So besides, we start from the back, so then we go from there. So 1, 2,
Should I use this?
4. The last.
Hi, Paul. Thanks for the very interesting talk. So I was wondering about like forward signaling, like this program. So I discovered that now it seems so did it become aware or still forward? It was not planning. So what's the transition there, right? I know people on the left know what it means.
Yeah.
But there's still a payoff. So that payoff will change. So
yeah, so
how does that work? Something that is in place.
Yeah, Let's Go Brand. Thank you. Let's Go Brandon is a really interesting case, and we talk about it explicitly a bit in the NIS paper because we had to spend time thinking about it. So, for those who don't know, Let's Go Brandon was this thing that happened at a car racing event where people were yelling "fuck Joe Biden," and it was a racer who was named Brandon, and he was like, "It's great, everyone's saying Let's Go Brandon." And so that became a code for, F Joe Biden. And what's interesting about this is it was like, it seemed like maybe it was a covert signal for like a day. And then it was very immediately publicized in newspaper articles and on the news. So it wasn't really covert for very long. And what's interesting about political identity in the US is it's become, at least in a lot of places, so charged. And homophily is so easy and so strong that I think the incentives, this is actually one of the things that got this work going, is it seemed like the incentives changed. Like in the past, it was more incentivized to be covert. And then between online social networks and media and the big sorting where people live in communities that are different, and also, the people realizing that the law was not that good. There's been a lot more overt signaling of this stuff. So I wouldn't classify Let's Go Brandon as a covert signal. It was like sort of on the edge of covert for a little bit, and it might still be covert for some people, but I don't think it quite fits the pattern.
Thank you. We have number 2. Lama. No. You walk forward,
Hi, Paul. Thanks for your talk. I'm just like it should have stopped. So I was wondering how you think about the fact that we have multiple identities and they can signal different corporate signals at the same time. And I just wonder, I will probably make it more complex, but would your model be able to do these things in parallel? And also something that it may affect how one signal affects one person, another signal affects the same another person. So I just wonder how the interaction between different identities that may be saving at the same time would interact with each other.
Yeah, thanks. I really appreciate that question. That was actually, I mean, when I started working on this stuff in this kind of serious, what I think of as a serious, like more theoretically grounded way, that kind of question was really at the core of what was driving me. And if I have this 2019 paper published in Behavioral Processes that's just conceptual, there's no model, where I talk a lot about this exact fact, the multiple identity problem. And I honestly, at least at the time, couldn't figure out a way to easily model it. And so covert signaling kind of became well, that's also a related interesting problem. So I'm going to spend some time on that. Maybe I'll get to that. And it's something that I really, really want to get to. There's this, I just recently discovered David Walpert, who's at the Santa Fe Institute, has these kind of esoteric papers on persona games, which are these kinds of interesting game theory models about what kind of persona to adopt in different contexts. And it seems really ripe to expand on. So I'm interested in that, yeah.
Yeah, it might be also in seeing that discussion around it because it's a complex.
You can have a discussion in the coffee break. So watch the effect on us.
Yeah, I think this is really fascinating to me as a knowledge population biologist, but I'm also a trainer on cross-cultural issues. So I quite frequently find myself far away from the USA, in other parts of the world. And there I noticed that I was often approached by people from minorities from which they cannot change. You turn from a trumpet to a white voter, you cannot change from some kind of ethnic or religious minority so easily. And they saw me as a kind of neutral person they could confide, and they started to reveal their covert identity. So minorities in societies with a high cost of being disliked, they have these secrets burning them. I think that's what we found also in the moment. So it's a very generic and deep thing, also connected to in particular individualism and collectivism, but also other aspects of population level culture. But thanks, and what do you think about that?
Thanks. I mean, I agree entirely. That's a really important point. You know, part of a lot of discussions around this, like the models are necessarily simple, but you know, one of the things that really drove a lot of our conversations was the fact that identity and identity signaling is in truth iterative, right? Where it's kind of coarse grained at first that, you know, okay, do I just even approach this person, or do I run away from them, or do I attack them, right? And then, okay, once I've approached them, what kind of interaction can I have? What kinds of things, you know, are we going to be able to coordinate? What kinds of things would be strategic to reveal? And I think these decisions kind of keep going. I also, I guess, would challenge the idea that ethnicity can't be masked to some extent, right? Sometimes it can't, but you know, there's also the phenomenon of passing. Yeah. 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 So yeah, I think there's a lot of, I think there's open territory for it, and I think it's important.
So this is fascinating. Thank you very much. I have in this very short time, I would like to have multiple questions. But the first one is that there are a lot of punishments. So basically, that if you are having a covert signal and you are found that you are in a case of participants or mafia signals, for instance, then there are actually actions from the side of those who found yourself in this situation that basically also might be costing. So it consider this kind of situations is part of the data structure. And one of these signals, and also the second part of the question, is that targeting the outcome. So if I have, especially in a participant signals or mafia case, then we really want to destroy the majority, or fail is basically increase difficulty if we do something. And so it's also linked to the third part of the question that how do you find this out, especially on Twitter?
Yeah.
If these are really covert signals, then the good covert signals you don't find.
Okay, yeah, thanks. There's a lot there. I don't know how you find it on Twitter. I'm actually, so one thing you mentioned though, I'm involved in a project now looking at sort of online trolls on Reddit. And I think that Reddit in particular is fascinating But also Twitter, to some extent, is because one of the things that Reddit has that sort of past societies didn't really have is anonymity. And anonymity totally changed the signaling game. We have so bad, like almost no theory about how people signal in general when they can be anonymous in this way, but still sort of can act in a group beneficial way. So trolling is this really kind of like owning the libs kind of thing. And most trolls don't troll publicly. They troll, well, they troll anonymously. And it sort of changes the nature of the beast. And the answer is, I think there's a lot of really interesting questions. All I'll say is that one of the books that's like, while I was working on this, that was really influential to me was Codes of the Underworld by Diego Gambetta. And that's sort of all about these like really nice data and game theory models about how criminals and mafiosi communicate, and really interesting incentive structures for these kinds of disadvantaged groups or groups that have different, are embedded in other groups with, let's say, partially antagonistic goals. And I think that, yeah, I think there's a lot of open territory, like I said, for this kind of work.
Well, we have one final question from online, and it's Norman. And I do notice from previous sessions that Norman sometimes has a very loud microphone. So the tech crew is happy to save our ears. Norman, can we hear your question, please?
I couldn't really tell what you said, but I'll continue.
Keep speaking and
Still not getting it. But let me continue. So thank you, great talk for those of us who believe that social identity is often a missing signal in social sciences. So a question or an observation maybe you can comment on is, doesn't signaling really depend on the kind of maturity of the social group, not just their power? So an example would be the military, their maturity. So let me just give an example. The military they're a very mature social identity group, and they have static signaling that, is very visible, but incomprehensible to people like me, an outsider. So it's not covert, but it's still incomprehensible. And teen signaling would be kind of just the opposite. They're not very mature, and it's always changing. So.
Okay, thanks. I'm not sure I totally know how to define group maturity here, but let's say that maybe what you mean is kind of permanence, or how established a group identity is in a population.
Yes.
So yeah, okay. Yeah, I think that's definitely true, and I think that understanding these kinds of phenomena in a way that is embedded in a larger theory of human behavior, like again, I'll point to Boyd and Richardson as and related ideas as like a good foundation for that. I think is really important. I wrote a paper in 2014 called "The Cultural Evolution of Emergent Group Level Traits," that kind of tried to talk about a bunch of these kinds of things, but I found it to be really, really difficult to model the kind of differences of different kinds of groups and different, some are really have a lot of lasting staying power, some are really ephemeral, some are embedded in other groups. And I think that there are a lot of modeling techniques that have emerged since then and around then, like multi-layer networks and cultural group selection and other kinds of things that are useful in thinking about different kinds of incentives and cost benefit outcomes that interact with one another. I don't think that my model, certainly my work doesn't speak directly to any of that, but I agree that it's important.
Thanks again, Paul, for this presentation and the Q&A. And now we move to the more event. All the prizes will be on that.
Nice book.
Yeah, it doesn't have a cover yet.
Yes, you told me. Yeah,
Yeah.
I would pre-order.